Alright, hell yeah. So today we're going to go over rolling friction and sliding friction. And hopefully we'll learn something. And this is just going to be kind of a go for it video, so if I say anything wrong, you know what I mean, shame on me. But hopefully we get a lot of things right. So this is a sloped ramp, and the first thing that we're going to do is do this Irodov problem, where if you get a ramp and you slope it where this thing just barely has enough static friction to hold itself, what happens if you impart a velocity this way, it doesn't just keep going that way. It'll stop going this way and then slide down the hill at a constant speed. So we're gonna think that might be what we end with. Okay, so that's kind of that's like the most complex thing you could do, visualize for sliding friction. So then what we're going to do is rolling friction. So we still have the same slope, and I'm going to try to get it just kind of perfectly lined up, and I'm going to have it roll across. See, there you go. So I can get this thing to just roll straight across. And this is one of the properties of rolling friction, is that in this case, once I imparted velocity, it's no longer a static situation. It's a moving object. But when we have something rolling, the contact point is always a stationary stationary contact point. So when you have pure rolling of a wheel, you have static friction in this direction, and you even have static friction in this direction. You know what I mean? So if you put your car just on a steep enough hill, you know what I mean, where if you're on maybe one of those drawbridges that goes up, maybe you got stuck on it, and you know what I mean, at a certain point your car will just start to slide backwards. And even if you're trying to drive up the drawbridge, you're going to get to a point where, hey, let's say your wheels are moving, but now you're sliding backwards. So even though your wheels are moving, you're going to be sliding. So hell yeah. Okay, so I think that's kind of in a nutshell. This was kind of the cool part of the demonstration, but I'll show you that this really only works with a long rod to go straight across, because I try to do it with this smaller wheel of tape, and what happens is it takes a curved path. So you're like, well, is that the same thing as this? And I would say no. Like this is the tricky thing about physics, is there's never one thing going on. Like, I consider this almost like a representative of a bicycle. A bicycle has like at least three or four major things going on, and a lot of people will point to different things of a bike, like the trail of a wheel. And you know what I mean? Everybody points to the trail of a wheel, you know, with the fork, and it's so dumb, because a bike is mainly something that is moving across. You know what I mean? A bike is like, this is a bike. You know what I mean? It doesn't seem like it, but a bike is this moving across, and then if I turn it, I have the center of mass wants to, like, you know, go to the outside. But with a bike, you are anyway. A bike has like two friction. Man, I'm gonna go down a rabbit hole. But a bike has two wheels that have friction, and they still have that same static friction. So the second you turn this wheel, like, hey, everything wants to fly out this way. Yeah, so that is true. So if I turn my front wheel, like, hey, this bike just wants to flop over. But that's kind of useful, because then I can, you know, when I turn my wheel, I have to kind of lean this way to compensate that, because I have, again, I'm going this way, I turn this has a lot of friction, and I just set its path this direction, and it can't slide this direction, and so the whole bike wants to flop over. But if you are leaning into a corner, then hell yeah, you can lean the bike over, and then kind of go that direction. So that's the same thing that's probably kind of happening here. The other way to look at it is that, well, yeah, I think that's the best way to, I think that's very similar of what's going on, why this thing actually wants to turn. But that's separate from the issue at hand of talking about rolling friction. And the friction is just enough, that's the thing, is like the friction is just enough to make sure that like this is continuously, you know, it's not doing this like twice as fast in rolling, and then it's also not doing the other thing of, so it's not going twice as fast and then going at half speed, and it's also not going at a half speed and then doing this. That's skidding, and this is like a burnout. So there you go. Those would be the two different things. So when something is rolling, and when it has the right amount of friction, it'll just roll. And oh man, see, I just want to do this video in one shot, but it seems like where my mind was going is just like, well, it seems like that's like almost an unstable balance point. It's just like, well, there's just this one perfect spot where you get enough friction to make this thing roll, and I don't think that's the case. It's just like statics. It's like, hey, this thing's not moving, you know what I mean? We can adjust the angle of this, and it's still not moving. So we have a large, we can put a variety of forces on this, you know what I mean? This is just the point where the force is the max. So when something is in static, you know, equilibrium, and there is friction, static friction, yeah, you can put a force on it, you can put forces on it up to a limit until hell yeah, then it's no longer in static equilibrium. Same for, you could imagine that for a car wheel. You know what I mean? In an ideal situation, there is no sideways forces making your wheel. Where'd my tape go? Because, you know, I did the bicycle analogy, so let's switch front wheels. If this is the bicycle and then I turn this wheel, hey, you could like, probably the mountain bikers that are professional, they could do a skiddy. You know what I mean? You turn this wheel, it's kind of nice and flat, and then you can kind of slide this front wheel around a corner. So that's one thing that you can do. It's a very difficult maneuver. Oh. All right, so what else? So then there's that. If this was a bicycle and I turned it and I could slide it this way, hell yeah, it's sliding this way. So that's probably the easier way to envision a sliding wheel, is if the wheel just got cocked sideways and then you're sliding. But the same thing happens even if it's rolling. If I'm rolling down the hill and then all of a sudden, you know, just imagine that I have I have my foot on the gas, the wheels are spinning this way, I'm moving this way, but now I'm on that drawbridge and it gets to be a steep enough slope that the wheels just start slipping. Okay, perfect. Yeah, now I know. I was contemplating what a frictionless surface is before this video. And so let's just say, like, right when that drawbridge gets up to a certain height, you also hit an icy slope. So your wheels are still going this fast because you had it on the gas, but then you're just hitting a frictionless surface. So now you're traveling like way faster than your wheels are spinning. So in that case, and so let's see how much time we got. Yeah, we're going to make a 20-minute video. But we'll see. So then there's this other aspect of, I think it's good to visualize what's a frictionless surface. Because, yeah, so this was fast. I could have a car drive down a very grippy road and then hit a sheet of ice. And so what's going to happen is, so right here we have rolling friction, you know what I mean? It's the wheel's not sliding and the wheel's not burning out, and so we're just rolling down the hill. And then once we hit this chunk of, and then so no gas, we're just allowing the car to roll down the hill, and then we hit this patch of ice. What happens? Like nothing. Like literally the wheel just keeps going. So I think one way to visualize what's happening when you're on a grippy road with a rolling wheel and then you hit a patch of ice and you're just letting gravity do its thing is the same thing of taking that car, picking it up, and then just hovering it in space. And then, like, so I always like to use, like, hey, if this is the only thing, like, take objects to outer space and even make them the only thing in the universe. So we have this car, it's rolling down a hill, and then you just instantly pick it up, and it's the only thing in the universe now. The wheels are just going to keep moving at that speed forever. The car is also going to be moving at the speed it was going down the hill forever. So we can... I think that is an easy thing to visualize just because we know, like, Newton's laws, you know, in space there's no friction, things just, you know, kind of move forever. But that's the same thing that happens when your car goes over an icy surface, and I think that's fascinating. So now let's take this wheel and pretend like it's in, like, the only thing in the universe or just in outer space, and we give it some sort of motion. So we spin it with some sort of velocity or angular velocity, and then we take like two icy surfaces and we start to squeeze this wheel. So this wheel's spinning in outer space, and we take these frictionless surfaces and then we tried to squeeze this wheel. Now, is this wheel going to slow down? And the answer is no, but it's just very difficult to imagine a completely frictionless surface. You know, even like an ice skating rink isn't zero friction, you know, even if it's nice and wet and stuff. So yeah, I just think that is a fascinating aspect, you know, so anyway, so hell yeah. How much time do we have left? Got about 7.5 minutes. So those were the aspects of rolling friction that I thought were important. And it was just kind of cool to do this experiment, and it worked. It's only going to work with like a long dowel. Like if you have a wheel like this, hey, you got that other aspect of, you know, the center of mass is right here. And I don't know. Yeah, I'll have to figure out exactly why this thing just rolls and makes an arc, where this thing, hell yeah, you could just get it going straight across, even in the other direction. So hell yeah. Alright, so what else about rolling wheels? I think that's about all I wanted to do, and so let's just end it there. So thanks for joining me, and guess what? That's a video.